Here's our final video, and we'll be covering bubbles 25, 26, and 27 in lesson 10. One component of the AP Create performance task is describing an abstraction within your program. So we have done a lot of work with abstraction, so this one should be easy. Capture and paste a program code segment that contains an abstraction. This abstraction must integrate math and logical concepts. Explain how the abstraction helps manage the complexity of your program. Here is, we're basically looking at row 8 and in response to D. Here is the abstraction that has been noted. And they want you, in this case, to write your own response to 2D, describing the abstraction and talk about how it uses math and logical concepts. How does it manage the complexity of your program? Stop the video. Take care of that. Okay, in terms of answering the question to get the row, in order to earn credit, the response should discuss how the function selected manages complexity. One response could be that by placing this code in a function, it can be called from multiple places in the program without duplicating code. The fact that the function is parameterized, which means we send a parameter to the function, also helps manage complexity since it generalizes the behavior of the function, allowing it to change the score by an arbitrary amount. Without this parameter, it's conceivable that additional code or even additional functions would be necessary, which would add complexity to the program. Finally, though this is the weakest argument, you could state that simply creating the function allows you to give a more understandable name to a large block of code which clarifies its purpose. Regardless of the argument presented, you should be looking for the student to make a case that the creation of the function is helping manage complexity. Let's move on to bubble 26. One component of the task is to select an algorithm. So you're supposed to mark with an oval the segment of the code that implements the algorithm you created for your program that integrates other algorithms and integrates math or logical concepts. Row 4 of your rubric is looking for the selected code segment implements an algorithm. Row 5, in terms of applying algorithms, the selected code segment implements an algorithm that uses math or logical concepts, explains how the selected algorithm functions, describes what the selected algorithm does in relation to the overall purpose of the program. And finally, row 6, selected code segment implements an algorithm that includes at least 2 or more algorithms. At least one of the included algorithms uses math or logical concepts, and explain how each one of the included algorithm functions independently. Now, responses are still eligible to earn this row even if they do not earn 5. The included algorithms can be subparts of the algorithm in row 4. Okay, so let's take a look. The program code below is taken from Color Sleuth activity you just completed. So you can see we have different parts of the code circled and labeled with letters. Write which of the ovals is placed around the code that best meets the criteria as a student-developed algorithm. Explain your answer using the criteria in the scoring guideline. So remember, we're looking for a parent algorithm that calls two children algorithms. So I'm going to ask you to stop the video, come up with an answer, and turn the video back on when you're ready. Okay, so the best answer here is D, and that's because both the parent and the child algorithms are all circled. They use math and or logical concepts. And let's talk about the rest of it. Oval B is around the set board function. The function does not clearly meet the criteria since it does not have two obvious children. Oval C is around the switch player function. This function does not meet the College Board definition of an algorithm. There are no obvious children which work independently. Oval A might count as an algorithm. It uses math and logical concept and calls on at least two children algorithm, which themselves use math or logical concepts. All parts of the algorithm consist of more than merely library calls. Nevertheless, this oval is not placed around the code of the child algorithms. So while this might meet the bar, the best option would be to include the code from at least two child algorithms in the ellipse and choose oval D. Okay, so in summary, they want you to put a circle around the parent and the two child algorithms, not just the parent. Let's move on to the final bubble. One component of the task is to describe the algorithm. We are going to look at rows 5 and 6. Selected code implements an algorithm that uses math or logical concepts. We explain how the selected algorithm functions, and we describe what the selected algorithm does in relation to the overall purpose of the program. Row 6, the code segment implements an algorithm that includes two or more sub-algorithms. At least one of the indicated algorithms uses math or logical concepts. Explain how one of the included algorithm functions independently. The code selection is taken from Color Sleuth and would count as an algorithm. Write response to C, describing the algorithm above. Use the writing prompt and scoring guideline as a guide. Here are the main points you must include. Name your main algorithm and each of the two sub-algorithms. Clearly identify them by their function name. Explain what each sub-algorithm does and how the code of each actually works. Explain how the main algorithm works and how it helps achieve the purpose of the program. Go ahead and stop the video. Okay, now in terms of a solution, the response must include all of the following items that were listed above. Identifies the main algorithm as check correct function and the sub-algorithms as set board and switch player. Explicitly explain what each sub-algorithm does and how it works. Set board sets the colors of each individual button on the screen to a new random color and then changes a random button's color by a little bit. To do this, the program first generates a random RGB value. Notice how we're referencing the lines 33 through 35, and that's recommended that you do that. So it's very clear to the grader that you're talking about the code and how it works. Then assign all the buttons that color, again, references to lines in the code. Then randomly select a button to be assigned a slightly different color. Switch player switches the current player in the game. It does this with a single if statement, which then changes which player's name is highlighted. The other thing we were looking for is for you to identify the main algorithm, what it does, and how it helps achieve the purpose of the program. Check correct checks whether the button clicked is the correct one. It then updates the score accordingly. Afterward, it checks whether the game has been won before using set board and switch player to both reset the board and switch the current player in order to prepare the board for the next player's turn. This algorithm, therefore, is important for the overall purpose of the game progressing from turn to turn so that it can be played. Thank you.